Okay, we have another question here. It says 4 grams of levofloxacin mixed with 500 ml of 0.9% sodium chloride solution is administered via slow IV infusion over 24 hours. If the IV set delivers 10 drops per ml, what will be the flow rate in drops per minute? So in terms of understanding the question, we interested in drops per minute, the flow rate in drops per minute. So this is most likely going to be administered by gravity, so it's in drops per minute. And so we need to figure out the path to our solution. There are a number of ways you can do it, but I tend to believe that using dimensional analysis would be like really expeditious for this type of a problem. All right, so because we want to end up in drops per minute, we need to identify the information that is presented that has drops in it and has drops as a numerator. And if we look carefully, the drop factor here, that's 10 drops per ml, has drops in the numerator and some other quantity in the denominator. So we don't really worry about that. We'll get rid of that eventually. You have 10 drops. So if you write that out, you have 10 drops in each ml. So we need to move from drops per ml to drops per minute, which means the next thing we need to figure out is we need a dimension of volume as a numerator and a unit of time, or a dimension of time, in the denominator. Now it so happens that it's not too confusing, this question, because the only volume quantity that you have here is the 500 milliliters, and the only time information presented is the 24 hours. So yes, you're going to be running 500 milliliters in a time of 24 hours. So at this point, the milliliters, or the units of volume, can cancel out, and you are now in drops per hour. But you don't stop here, because we're looking for, yes, drops per minute. So we need to get rid of the hour, and we know 1 hour is the same as 60 minutes. So we can cancel units of hours, and there we go. We are now in a dimension of drops per minute. So we are now, you see, the only thing left is drops in the numerator and minutes in the denominator. Okay. All right. So what it means is, if we multiplied everything in the numerator and divided it by everything in the denominator, we'll end up with our solution. Okay. So that's equal to 10 times, or 10 drops times 500 all over 24 times 60. And if you do that, this is 5,000. So the drops will be there. And 24 times 60, let's see, 24 times 60, that gives you 1440. And so that should be equal to 3.5 drops per minute. Okay, so that will be our answer, our solution. Our solution will be, to this question, will be 3.5 drops per minute. So if you notice, we didn't even have to touch the 4 grams. That was not even relevant for our question, for finding our solution. It's important in the question, but we were looking mostly at the information that is pertinent for this kind of a question, which was the volume that was given and how long it's going to be infused for and what the drop factor is. Those 3 were what was needed primarily to arrive at our solution.